Hello, myself Anjali Ramashankar Prasad. I am a PMRF scholar at IIT ISM Dhanbad. So today we are going to start with the week 5 assignment session, problem solving of essentials of topology. So let's just wait for 1 or 2 minutes so that others will join, then we will start. Uh, Good evening. Just wait for a few minutes and we will start. Good evening everyone. Okay. Okay, I think your problem is being solved. So I hope many of you have joined. So let's start with the session. Okay. So let's start with the week 5 discussion on problem solving. So I hope you all might have went to all the lectures of this week. So let's get a quick revision on that. So what you have been seen, I guess. So first start with the first countable spaces. So what is first countable space? A topological space X is called a first countable space if it satisfies. Okay, so a topological space X is called a first countable space if it satisfies the following axiom called the first axiom of countability. Okay, so we will call this axiom C1 as first countability of axiom. So what is it? That for each point P belongs to X, there exists a countable class BP of open sets containing P such that every open set G containing P also contains a member of BP. Okay, so basically if for every point P belongs to X, there should be a member of BP which should be contained in G. Okay. So in that case, we will say that our topological space is first countable space. Fine. In other words, a topological space X is a first countable space if and only if there exists a countable local base at every point P belongs to X. So in other words, we can also say that if for every point P there exists a local base, then we will say that it is a first countable space. Okay, I hope it is clear. So shall we move to the next part? Okay. So next is result on first countable spaces. So what is it? So let X tau be a first countable space. What are the results that we have? That let X tau be the first countable space, then there exists a countable basis, that is Bx. It will be of this kind. It will be collection of Cn such that n belongs to natural numbers at x belongs to x, such that Cn plus 1 will be subset of Cn for all n is equals to 1, 2, 3. Fine. So this is one of the result. We also called it as a nested basis. Okay. I hope you have visited through this result. Then next is let X tau be a topological space and A subset of X. Then if there is a sequence of points of A converging to X, then X belongs to A closure. Okay. So this is about the sequences. Then comes the second countable space. A topological space having countable basis for topology is said to satisfy second countability axiom or to be second countable. Okay. So if if the topological space have a countable basis, then we say that it is a second countable space. Okay, or we say that axiom as a second countability axiom. Okay, I hope it is clear. Okay, so next comes the properties that first countable space is based on having countable basis for each point, whereas second countable space is based on being having countable basis for the topology. Okay, so that is the basic difference between first countable spaces and second countable spaces. Fine. So basically every second countable space is first countable. Fine. You might have visited to the counter example also. Fine. So similarly a subspace of a second countable space is second countable. Similarly in first countable case also a subspace is a first countable space. Okay. Now comes separable spaces. So a topological space x comma tau is called separable space if it has a countable dense set. Fine. So if you have a topology on a space X, so if there exists a subset A of X such that A closure is X, that is it is dense, and if A is countable, then that space X comma tau is called as separable spaces. Fine. I hope it is clear. Shall we move next? Okay. So you might have this example for Euclidean. You can take rational numbers. Okay. So this will form a countable set, and then its closure gives you R. So R with Euclidean topology is separable. Fine. Now a subspace of a separable space may not be separable. Okay. Now open subspace of a separable space is separable. These are the properties you might have visited through. Now, what is the relationship between first countable space and separable spaces? That every first countable space may not be separable. Okay. So similarly, you might have visited through second countable space and separable space, all the relationships. So in a nutshell, we get that is every second countable space is first countable space. Also, it is a separable spaces. Similarly, first countable spaces may not be second countable spaces, and there is no relation between first countable spaces and separable spaces may not be second countable spaces. Fine. So these are the relations between all these three spaces. So next comes continuous function. So what is a continuous function? In real analysis, you might have seen the definition of real continuous function. So with respect to topology, what is it? So if let f from x tau to y tau dash be a function and x naught belongs to x, then f is continuous at x naught. If for each tau dash open set H containing f of x naught, there exists a tau open set G such that f of G is subset of H. Okay. So if you have function given like this, and you have to check the continuity at x naught. So just check for every tau dash open set in H containing that f of x naught, there should exist a tau open set G such that f of G should be subset of H. Fine. So also, if we change the topology, that function may not be continuous. Okay, so the continuity of this function depends on the topology. Fine. Now, similarly, you can define it with respect to the open sets. So, what is the definition with respect to the open sets? The function f from x tau to y tau dash is continuous if and only for each tau dash open set in G, there exists f inverse of G is a tau open set. Fine. Similarly, for closed sets, you can define it. Okay. Now, similarly for neighborhood also, we have a definition for continuity that let x and y be two topological spaces, then f from x tau to y tau dash is continuous if and only for each x belongs to x, and each tau dash neighborhood n of f of x, there exists a tau neighborhood m of x such that f of m be subset of n. Fine. So this is with respect to neighborhood. Okay. Now, with respect to bases, also we have the definition that is let x tau and y tau dash be two topological spaces, and if b dash is a basis for tau dash, then f from x tau to y tau dash is continuous if and only if for each b belongs to basis. F inverse of b is a tau open subset of x. Okay, so this is for basis. Now, for property for identity function is what? That if x tau is a topological space, then f from x tau to y tau dash such that f of x is equals to x, that is our identity function, is continuous if and only if when then tau is finer than tau dash. Fine. So similarly, we'll have for closure and on subspaces that you might have visited through this property that the two topological spaces, it is continuous, the function f is continuous if f of a bar is subset of f of a whole closure. Fine. Now we can also get it with respect to y. Okay, so if f is continuous if and only if f inverse of b whole inverse, if you taking inverse, then this property will be taken in consideration. Okay. Now on subspaces also you have the definitions and then relative, and then you can also have it for composition. Yeah, for composition of two continuous functions is also continuous, it has also been proved. Then you can form a restriction on the function. Okay, so that will be also continuous. Then similarly for question topology, and some property was given for projection. Fine. So this have been all discussed in the lectures. So I hope you might have visited through the lectures. So shall we proceed further if this part is clear to you all? Okay. So we can proceed further, right? Okay. So let's solve the questions. So the first question is, let BP is equals to set of B1, B2 dot 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 be a set, be a nested local base at P belongs to X, and let A1, A2 dot 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 this be a sequence such that A1 belongs to B1, A2 belongs to B2, and so on. Okay. So I hope question is clear that you have been given a nested local base at P belongs to X denoted by BP, and you have been given a sequence A1, A2 dot 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 such that A1 belongs to B1 and A2 belongs to B2 and so on. Okay. So the question is then uh, determine which of these statements is correct. So option A, is it option A that is sequence A n may not converge to P, or is it option B that is sequence A n converges to P, or is it option C that is sequence A n does not converge to P, or is it option D that we cannot determine convergence of sequence A n? Okay, so all of you try this and try to prove it clearly. and we will discuss what you are getting. Is it convergent or not convergent? If it is convergent, then why? And if it is not, then why? So let me know your answers. Everyone try it. So you are saying that correct option is B. Okay, let's other also try. What are they getting? Others, are you also getting option B or still trying? Take your time and let me know your answers. Okay. So all of you are ready with the answers. So shall we move to the answer part? Okay. So let's see the answer. Yes, the correct answer is option B. So how will we get it? That you have been given the so the correct answer is that sequence AN converges to P. Okay. So how? Let G be an open set containing P. So since BP is a local base at P, so there exists N naught belongs to natural numbers such that since it is a local base, so we will have some Bn naught belong to BP such that Bn naught will be subset of G. Fine. But also we know that BP is nested. So hence for all N greater than N naught, it will imply that An will belongs to our Bn naught. That is subset of G. Okay. And Since it is true, so we will say that AN converges to P. Fine. So I hope it is clear to everyone. Okay. So shall we move to the next question? Okay. So the next question is, let BP is equals to set G1, G2 dot 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 be a countable local base at P belongs to X. Okay. So this have been given you a countable local base at P belongs to X. Okay. Then which of the following statements is correct? So you have to determine which of the following statements is correct. So first statement is that there exists a nested local base at P. Okay. And option 2 is that if X satisfies axiom first of countability, then there exists a nested local base at every point P belongs to X. Okay, so let me know which of the options is correct. Is it only first, only second, or both first and second, or neither first nor second? Okay, let even try to prove it. Just write the proof if you are getting the correct answer so that we can discuss its proof as well. Okay, some have answered it as option C. What about others? And even try to prove it. Okay, you are saying about the doubts in Google group. So actually, I discussed with it with the sir also, and then you get the reply. Also, the I have seen your recent questions also. So in one of the question that you asked about that uh, about continuity, right? That x that point belongs to that open set or not. So sir replied yes, and you were asking about that. So it is, yeah. So it is obvious, right? For the continuity, you should have that point in that open set G. So that was what sir saying, that yes, it is obvious that that x naught will belongs to our open set G. Okay. So that was the reply got to you. Okay. And other questions that you have posted, so we'll try to answer it by uh, tomorrow. Okay. Yeah, I saw that question about question map. So even or I'll ask, even if sir, then anyone of you, us will give you the answer required. Okay, fine. So is everyone ready with their answers? Others, shall we move to the answer part? Okay. So the correct option is C, that is both 1 and 2. So why so? So if set B1 is equals to G1 and B2 is equals to, you can consider B1 as G1 and B2 as G1 intersection G2. Similarly, Bn as G1 intersection G2 intersection dot 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 Gn. Then you can see from this construction that B1 is superset of B2 and so on. Okay. So each BK is open here and it contains P, obviously, right? Now, further, if G is an open set containing P, okay, so obviously there will exist some N naught belongs to our natural number. Okay, so if we have got the open set G containing P, okay, so for all N greater than N naught, we can find that such that B N naught will be subset of G N naught, which will be subset of G. Fine. So accordingly, this will form a nested local base at P. Okay, so you will always get a nested local base at P. Now the second option was that if X satisfies first axiom of countability, then there exists a nested local base at every point P. Okay, so from first axiom, what we have? For first axiom of countability, what we have, that for every P belongs to X, that there is a countable local base at P. Okay, that is from our first axiom of countability. Also, there exists a countable local base at P. Okay. Now by first, what we have seen that from the first point that there exists a nested local base at P. Okay. So if there exists a countable local base at P, so from first axiom and from the first property that we prove, we will get that there exists a nested local base at P. Fine. So I hope it is clear how we are getting both the properties. Okay. So if it is clear, so shall we move to the next question? Uh, I hope the presentation slide is visible to you correctly, right? There is some issue with the Google Meet. I'm unable to zoom in. So presentation slide is okay with you, right? So we can carry on. Okay. So let's move to the next question. So the next question is, let tau be the topology on the plane R2 generated by the half open rectangles. Okay, so these are our half open rectangles, that is closed A, comma B, cross closed C, comma D. Okay, open at D. This is given by set x comma y such that x lies in between A to B, where a less than equals to x less than b and c less than equals to y less than d. Okay, so then r2 comma tau is separable. So is this statement, that is r2 comma tau is separable, is it true or false? Okay, so you need to determine, is the statement r2 comma tau is separable is true or false? Okay, so here you have tau as a topology on r2 generated by this half open rectangles, and determine, is it separable space or not? Okay, so everyone try it and let me know your answers and try to prove it, if it is or if it is not. I hope the question is clear to you. These are the half open rectangles, closed at A and open at B, cross closed at C and open at D. So if you are ready with your answer, then please be also ready with your proof. Okay, so if you are saying it is separable, then why so? And if it is not, then please give a counter example. Okay. So I hope you are all ready with your answers. Okay, you have explained it all as well that if we are taking ABCD of from rationals, then it will form a countable base for the above topology. So is everyone agreeing with that? Shall we move to the answer part? Okay. So yes, it is true that if we have a topology tau on plane R2 generated by half open rectangles, then it will be having that R2 comma tau is separable. So how so? There are always rational numbers x naught, y naught, such that if we are taking our half open intervals, that is a comma b, so we will have any rational number x naught in between this, right? And similarly for c comma d as well, we will have a rational number y naught in between that. Okay, so the above open rectangles contains the point. Always this rectangle a comma b cross c comma d, this will contain this point p. Okay, that point p is denoted by x naught comma y naught. Okay, where x naught and y naught are rationals. Okay, with rational coordinates. Hence the set, if we are taking our set A denoted by q cross q, that is rationals cross rationals, we are taking cross product of this. So it will consisting of all points in R2. It is consisting with rational coordinates. Then it is what? It is dense in R2. Why? Because q cross q, if we are taking its closure, then it will be r cross r. Fine, because closure of q is r and closure of q is r, so it will give you r cross r, that is r2. Okay, but so we have shown that we have got a subset A of r2 such that its closure is r2. Okay, so we are getting its closure as the whole set, so we can say that A is dense in our R2. Okay. Also, A is countable set. Why? Because it is consisting of rational numbers, and since rationals are countable, so A is also countable set. Fine. So we have got a subset A which is dense as well as countable. Okay. So by the definition of separable spaces, we can say that R2 comma tau is separable. Fine. So I hope it is clear the proof why the topology on R2 generated by this half open rectangles are separable. Yeah. So I hope it is clear to everyone. Is there any doubt? Is it second countable? So what is your point? What do you say about it? For second countable, what do we need? We need a countable basis, right? Yeah. So we need a countable basis. So yeah, it will form a second countable space also, because this will form the countable basis, right? Q cross Q. Okay. So I hope it is clear. Is there any other doubt? No, Q cross Q, not Q cross Q, but you can take this rectangle as a basis. Uh, this half open rectangles. Yes, you can take endpoints from rationals. Yeah, okay. So, is it clear to everyone? Shall we move to the next question? Anyone has doubt? Or is it clear to everyone? Okay. So, shall we move to the next question? What product of? So, first, let's discuss the questions from from this context, and then we will move to your general questions. Okay. So, is this particular question clear? Okay. So, let's move to the next question. So, the next question is, consider the function f from R to R defined by f of x is equals to this, that is x minus 1 if x is less than equal to 3, and a half times x plus 5 if x is greater than 3. Okay, then which of the following options is correct? First one says that inverse image of every open set in this codomain is open in domain of this function, and second option is that f is continuous. So which of these options is correct? Is it only option 1, only option 2, or both of these is correct, or neither of them are correct? So everyone try it and let me know your answers. I hope the question is clear to you. You have been given the function f of x defined in this way, where if the x is less than equal to 3, then it will be x minus 1, and if it is if x is greater than 3, then it will be half times x plus 5. Okay, you need to determine which of these options is correct. So you all are saying that option D is correct. That is neither 1 nor 2. Check once again. Are you all sure that it is the correct answer? Okay, so shall we move to the answer part? Or trying? Let me tell you, it is not option D. So if I say that it is not option D, then what is your answer? How it can be like if it is not a D, then it will be C that both. Okay, let's move to the answer part. So see the question once again, what you have been given, that consider the function f. Okay, so function is defined as f of x is equal to x minus 1 if x is less than equal to 3, and it is half times x plus 5 if x is greater than 3. Okay, and you have these two options. That first one says that inverse image of every open set in codomain is open in domain, and second says that if is continuous. Okay, so let's see the answer. It is B, that is only 2 is correct. No, it will not. It is not 2. Yeah, it is correct that neither 1 nor 2. Okay, this I have written incorrect. The correct option will be D, that it is neither. You will get the inverse image of all the open sets open in the domain as well. So it will not be continuous. Okay, how? Because the inverse image of the open interval 1 comma 3, if you are taking 1 comma 3, so it is what you will get, the open closed interval 2 comma 3. Okay, which is not an open set. Fine. So first thing is not true from this, and you have the theorem that a function is continuous if and only if the inverse image of every open set is open. Okay, but here we got one open set whose inverse image is not open. Fine. Hence f is not continuous. Yes. What inverse image? Yeah, inverse image of 1 comma 3. What about that? Till 3 it is defined as x minus 1, right? How 2 comma close open 3, why? Here it is closed at 3. 1, 2. Okay, see here. According to our map, f of x is what? X minus 1 if x is less than equal to 3, right? So for all x less than equal to 3, you will get this curve, right? Till here. Okay. So it will be up to what? As it is, f of x is equals to x minus 1. So for 3, it will be 3 minus 1, that will be 2. Okay. So it will be up to 2. Fine. We are just seeing the map. First, we are seeing the map. So for the inverse of the open interval 1 to 3, if you are taking this 1 to 3 open interval, so what will be its inverse image, right? Here it is half times x plus 5. Okay. So we need this, right? So at 3, what will be your image at 3? Image at 3. This is for what? X less than equal to 3, and this is for x greater than 3. So at 3, it will satisfy this thing. So image will be, for this, the image will be 2, right? Here you will get y equal to x minus 1. So x will be y plus 1. Okay. So for 3, you will get the image at 4. Yes, at 3 it will be 4. Okay. And what about for 2? For 2, the inverse image will be of the open interval. Okay, for 2 you will get for 2 you will get what? For 4. Okay, you are saying that for 2 to 4. So for 4 you will get um so when you are getting it as for 2 you will get 1, right? For 2 you will get it as 3. Okay. So now you are saying that, okay, yeah, it will be for 4. Okay. So you will get it for 2 to 4. Yeah, you are correct. Okay, so if you are taking the set as or 2 to 4, then you will get 2 to 3 union 3 to 4, right? Okay, so is it correct now? Wait. If you are taking it as mm, open at 1 to closed at 3, then see what you are getting. And then you will get next as union from here. Basically, wait, if you are taking 2 comma 3, then for 3 you are getting as answer as 4. Fine, at 3 it is 4. Now for 2 what you are getting? For 2 you are getting 3, right? Okay, so taking inverse image of 2 comma 4, what is giving to you? If you are taking 4, then what you will get from that? Y will be what? So from here you will get, right? So if you are taking 4, so you will get 3. So inverse image of this, and for 2 you will get, for 4 what you are getting the inverse image? Yes. And for 2, yes, for both of them you are getting 3, right? So it is not open in that sense.
मैम 2 to 4 लीजिए ना, फिर इसको ब्रेक कर दीजिए 2, 3 पर, और 2, क्लोज 3 यूनियन ओपन 3, 4।
तो उससे क्या होगा?
तो फिर ये हमारा बनेगा ओपन 3, क्लोज 4 यूनियन ओपन 1, 3 ओपन। तो ये क्लोज नहीं है, ओपन नहीं, सॉरी। मतलब इसकी इनवर्स इमेज जो 2, 4 की आएगी ओपन 2, 4, ये आएगी ओपन 3, क्लोज 4 यूनियन ओपन 1, 3।
Okay, so you are getting the interval, right?
यस मैम, और ये ओपन नहीं है ना,
ये
मैं दे रखा है मैम, देखिए 1, 3 यूनियन ओपन 3, क्लोज 4 इसकी इनवर्स इमेज आएगी, तो ये ओपन नहीं है।
और क्योंकि तुमको ओपन क्लोज इंटरवल मिल रहा है तो वो ओपन नहीं रहेगा, राइट?
यस मैम, अब ये आपने जो 1, 3 लिया है ना, तो
हाँ,
इसकी जो इनवर्स इमेज आएगी वो ओपन 2, 4 आएगी, बिकॉज यू आर नॉट इंक्लूडिंग 3। उसने
ओके।
3 नहीं इंक्लूड किया है ना, तो उसमें क्लोज 4 कैसे आ जाएगा?
क्लोज 4 नहीं है, वो 3 है, क्लोज 3 है।
3 भी नहीं आएगा, 4 आएगा, लेकिन क्लोज कर रखा है ना आपने, क्लोज ये रेड कलर
हाँ,
से जो कर रखा है आपने,
हाँ, हाँ।
तो क्लोज नहीं आएगा ना, वो ओपन आएगा। ये मतलब ये वाला एग्जांपल काम नहीं करेगा आपका काउंटर।
ओके। ओके, क्योंकि 3 पे हमें मिल जाएगा।
Inverse image of 3 is 4. 3 is not included in that set, that interval.
हाँ, क्योंकि 4 का इमेज आपको 3 मिल रहा है, राइट?
Yes, ma'am. And 3 is not included. So
बट 2 का भी
4
इमेज,
at 4
2 का भी इमेज।
हाँ, 2 पर ओपन तो है ना आपका, 1 को
हाँ।
इंक्लूड नहीं किया आपने, तो 2 पर ओपन लिया है आपने। वैसे ही 3 को इंक्लूड नहीं किया तो 4 पर भी ओपन लेना पड़ेगा।
ओके ओके,
Yes,
सो गॉट इट, राइट?
yes, ये 2,4 की आप एक बार निकालिए ना इमेज, 2,4
ओपन
इसको
टू
ब्रेक करके जैसे मैंने बोला। यस मैम।
ओके, ठीक है, मैं ये देखती हूँ, तब तक आप लोग फिर नेक्स्ट क्वेश्चन सॉल्व करो, ओके? ओके, सो नेक्स्ट क्वेश्चन इज, consider the identity function I from x comma tau to y comma tau star. Then I is continuous if tau star is subset of tau, and second option is tau is subset of tau star. So which one of this will be true? So you are saying that option A, right? Others, all of you getting option A? Okay. So it is straightforward. You have seen its proof in the lecture videos as well. That if you have a identity function from x tau to x tau star, then I is continuous if the tau star is coarser than tau. Fine. So, or you can say that tau is finer than tau star. Okay. Why? Because by definition, if I is tau tau star continuous, how? If and only if G belongs to tau star, that implies I inverse of G will be, that will belong to tau, right? Because it is the identity function. So I inverse of G will belongs to tau, but I inverse of G is what? G itself. So I is tau tau star opens continuous if and only if G belongs to tau star. Fine. So this implies G belongs to tau. So if we have taken G from tau star, we are getting G belongs to tau. That is tau star is uh, coarser than tau. Okay. So let's move to the next question. The next question is, suppose a function f is from x tau 1 to y tau 2 is not tau 1 tau 2 continuous. Okay, you have been given a function f that is not tau 1 tau 2 continuous. And if tau 1 star is a topology on x coarser than tau 1, and if tau 2 star is a topology on y finer than tau 2, that is tau 1 star is subset of tau 1 and tau 2 is subset of tau 2 star. Okay, so these are the all conditions you have been given. Again, I am repeating that function f is from x tau 1 to y tau 2, and it is not tau 1 tau 2 continuous, and also you have been given that tau 1 star is coarser than tau 1 and tau 2 is coarser than tau 2 star. Okay, so which of this following statement is correct? Is it f is tau 1 star tau 2 star continuous, or f is also not tau 1 star tau 2 star continuous, or f may not be tau 1 star tau 2 star continuous, or we cannot say anything about their continuity? So what is the correct option? Let me know. Okay, you are saying option B. Others, what you are saying? Even prove it. Why so? Others, what you are getting? Prove it. Okay. So, is everyone ready with their answers? Others? Others, what are you getting? Shall I repeat the question? Let me again repeat the question. Question says that f is from x tau 1 to y tau 2 and f is not a tau 1 tau 2 continuous function. Okay. Also, you have given that tau 1 star is coarser than tau 1. That is all the open sets in tau, that is all the open sets in tau 1 star will be also open in tau 1, right? That is tau 1 star is subset of tau 1. And other thing is given that tau 2 is subset of tau 2 star. Okay. Then what will be the conditions? So just try to prove it what you are getting. Shall I explain it? Or you are trying? Okay. So the correct option is C. That is F is also not tau 1 star, tau 2 star continuous. If we have been given that tau 1, tau 2 is that function f is not tau 1, tau 2 continuous, then correct option is C. That is f may not be.
मैम वो एक्सप्लेनेशन जो है वो मैम नॉट कॉन्टिन्यूस की है,
Oh,
वो गलती
sorry.
से बता दी बी।
It is
नहीं मतलब मेरा
B.
गलत है, मतलब ऑप्शन मैंने गलत बताया है।
हाँ हाँ,
नहीं, ऑप्शन क्या है मैम? बी ही तो है शायद। फैक्ट
बी
लग रही
बी है मैं लिखने वाली थी। इस बी ऑप्शन है f is also not tau 1 star, tau 2 star continuous. Okay.
है।
So how we will get it? So you have been given that f is from x tau 1 to y tau 2. It is not continuous. Okay. Not continuous means what? If there exists a open set G in tau 2, what is continuity? That for every open set in tau 2, that is this part, you should have an inverse, that f inverse of that G should belongs to tau 1. Okay. That is the case when it is continuous. So if it is not continuous, what we can say that there exists G belongs to tau 2 for which its inverse image, that is f inverse G, does not belongs to tau 1. Fine. That will be the case, right? Now, if this part is clear to you, we have tau 1 star subset of tau 1. Okay. And tau 2 is subset of tau 2 star. Okay. So hence G belongs to tau 2. We have taken G belongs to tau 2. So if G belongs to tau 2, that means it will also belong to tau 2 star. Why? Because tau 2 is subset of tau 2 star. Okay. And also we have shown that f inverse of G does not belongs to tau 1. So if f inverse of G does not belong to tau 1, then how it will be belonging to tau 1 star? Okay. So if it is not in the superset, then it will not be in the subset as well, right? So f inverse of G does not belongs to tau 1 star also. Okay. So from both this you are getting, okay, I'll see that. So from both of this, what you are getting, that there exists G in tau 2 star such that its inverse is not in tau 1 star. Okay. Therefore, it is not tau 1 star, tau 2 star continuous. Okay. Is it clear? Shall I explain it? So it is simple that if f is from, yeah. So it is simple that if f fixed from x tau 1 to x tau y tau 2, and if it is not continuous, then you will get a open set in tau 2 which inverse is not belonging to tau 1. Okay. And here tau 1 star is subset of tau 1 and tau 2 is subset of tau 2 star. So if you are taking G from tau 2, so it will belong to tau 2 star. And if you are taking f inverse of G from tau 1, that is does not belong to tau 1, that it does not belong to tau 1 star. So from both this, you can say that it is not tau 1 star, tau 2 star continuous. Okay. So I hope it is clear to everyone. And you were saying about your proof, that is because tau 2 is coarser than tau 2 star. Okay. And f is not tau 1, tau 2 continuous. Therefore, there exists an open subset in tau 2 and hence in tau 2 star whose inverse image is not open. How we can say that there exists an open subset in tau 2 and hence in tau 2 star. Tau 2 is subset of tau 2 star, right?
कॉर्सर है ना वो, टाउ टू इज कॉर्सर देन टाउ टू स्टार।
हाँ तो
सो एनी
इस
ओपन सेट इन टाउ टू, वो टाउ टू स्टार ही तो जाएगा।
हाँ 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 ठीक है हाँ समझ गए। तो वही तो यहाँ पे भी लिखा है, इफ यू आर टेकिंग जी
मतलब ठीक
फ्रॉम
है
द।
ना, बोल
हाँ 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 सही है सही है।
एक्सप्लेनेशन ठीक है
हाँ
बस।
सही है। सो इज इट क्लियर टू एवरीवन? Or still facing difficulty in this? Shall we move to the next question? Anybody has doubt in this? Shall we move to the next question? Okay. So the next question is, let f be a function from a topological space X into unit interval, that is closed interval 0 to 1, and if f inverse is f inverse of closed at f inverse of open at a comma closed at 1, this interval, and f inverse of closed at 0 comma open at b, these are open subsets of X for all 0 comma 0 less than a comma b less than 1, then which is the correct statement? Okay, so you need to find which of these statements is correct. That is it option A, that is a comma 1 and 0 comma b for a sub form a subbase for I is equals to unit interval 0 comma 1, or is it option B, that is f is continuous, or is it option C, that is f is not continuous, or is it option D, that is both A and B? So which of this is correct? You are saying that option C is correct. That is, F is not continuous. Uh, mm, Even prove it why it is not continuous. You are saying B, that it is continuous. Okay. So is everyone with their answer? B. What about others? Are you all getting option B? Yes. So we all saying that it should be option B. Okay. So let's move to the answer part. Is open C comma D forms subspace? Basis for subspace?
यस मैम।
How?
सी कॉमा डी तो आएगा ना 0, 1 में, मतलब किसी ओपन सेट से हम इंटरसेक्शन लेंगे तो वो आएगा उसमें फिर। कोई अगर एक ओपन सेट सपोज हम लेते हैं C, D, where C and D are between 0 and 1.
So
So
option A will not be correct or what?
option B should be correct.
और
I
ऑप्शन ए?
don't. इसमें मैम वो नहीं मिलेगा ना ओपन सेट। इंटरसेक्शन सपोज लेंगे इसमें तो फिर दिक्कत होगी। देख लीजिए।
इंटरसेक्शन तो सब बेस फॉर्म करने के लिए आपको चाहिए, तो आप इसके रिगार्डिंग ओपन सेट्स मिल रहे हैं क्या?
अरे सॉरी मैम, सब बेस है, सॉरी।
हम्म।
ठीक है मैम, सब बेस हो जाएगा।
हाँ।
सब बेस हो जाएगा, मैं सोच रहा था बेस सोच रहा था उसको, बेसिस सोच रहा था। बेसिस तो नहीं है ना ये।
नहीं नहीं, सब बेस की बात हो रही है।
सब बेस है मैम।
ठीक है, तो ऑप्शन कौन सा करेक्ट हो जाएगा?
डी, ऑप्शन डी।
ओके। Others, is it clear? So the correct option will be both A and B. Why? Because the intervals this open at A and close at 1 and closed at 0 and open at B form a subbase for the unit interval I, that is 0 comma 1. Okay. So by the theorem that um if S is a subbase for the topology tau star on Y, then F is continuous if and only the inverse image of every member of the subbase S is an open subset of X. Okay, so here we have been given that this the inverse image of this subbase, that is member of the subbase, is open subsets of X, that is already given. So by this theorem we can say that F is continuous. Okay, so the correct option will be both A and B.
मैम प्रूफ ऑफ द थ्योरम क्या आएगा?
क्या प्रूफ ऑफ द
ये
थ्योरम?
सर ने नहीं करवाया है मैम, ये थ्योरम जो आपने बोली अभी।
अच्छा, ये वाली थ्योरम दैट लेट x कॉमा टाउ एंड y टाउ स्टार अगर आपको दिया गया है एंड s अगर सब बेस है फॉर द टोपोलॉजी टाउ स्टार ऑन y, देन f is continuous if and only if inverse image of every member of the sub base is open subset of x.
यस
So
मैम।
इसका प्रूफ आपको मिल जाएगा, बुक्स में आप देखो, इजी
इजी
है।
है मैम, हो जाएगा। इजी है।
हम्म।
एफ
ठीक है।
इनवर्स ऑफ ए इंटरसेक्शन बी इज इक्वल टू एफ इनवर्स ए इंटरसेक्शन एफ इनवर्स बी, इससे हो जाएगा।
हम्म। ठीक है। और presentations are not opening in your laptop. Why? Try on
रीजॉइन करो।
this presentation, or you are talking about the presentation files that I upload?
भाई स्पीकर ऑन करके बोलो।
Uploaded file, right? So uploaded file you can try with Google Files, Google presentation files. Try with that. I have
रीजॉइन कर लो यार, ठीक हो जाएगा, रीजॉइन
no.
कर लो।
He's not talking about this current slide. He's talking about these presentation slides that I upload in the Google Sheet. I have form one drive, right? Okay, so I will upload in the form of PDF format.
मैम आपके पास और अलग से नोट्स हैं क्या, मतलब जहाँ से आप पढ़ती हैं?
अलग से नोट्स नहीं है, बुक्स है।
बुक से पढ़नी है? कौन सी बुक? मतलब
यू कैन
काफी कुछ आप नया बताते हैं इसलिए बोल रहा हूँ।
बुक्स आपको दे रखे हैं ना सर ने फॉलो करने के लिए।
अरे वो दे रखे हैं, पर आप कौन सी फॉलो
शॉम
करती हैं?
सीरीज वगैरह ये सब भी फॉलो कर सकते हो। और और बाकी
अच्छा।
सारे मुंकर्स की है।
मुनकर्स की तो बहुत खतरनाक बुक है मैम, समझ में नहीं आता।
ओके, So let's discuss other questions that you were asking in middle. One question you were asking about, right? What was that?
Product of two second countable spaces again second countable.
तो क्या होगा इसका आंसर?
I think yes.
Yes. So there is a like one theorem or kind of proof about कि product of countable second countable spaces is second countable. That is, if you will take countable number of second countable spaces and if you will take its product, then it will be again second countable.
Is it also true for first countable subspaces, I spaces?
No, I guess I haven't seen for that, but it is true for second countable spaces.
And what about for separable spaces?
So for separable spaces, you are talking about product.
Yes, ma'am.
So I don't have idea about that, but you can search about it. There are theorems regarding that it's a product. Okay.
मैम प्रोडक्ट में हो जाएगा शायद, क्योंकि जो क्लोजर होता है ना वो ए क्रॉस बी का क्लोजर इज इक्वल टू ए क्लोजर क्रॉस बी क्लोजर।
हम्म।
तो
तो
सपोज
हाँ,
अगर
उसका प्रोडक्ट लोगे तो वो भी डिफरेंट
हाँ
डिफरेंट आ जाएगा, राइट? ए क्रॉस क्लोजर,
हाँ
बी क्रॉस सबका,
यस
तो वो भी हो जाएगा।
हाँ, ये कुमरेशन अच्छी बुक है।
हाँ, कुमरेसन फॉलो कर
मैम
रहे हो?
कुछ प्लीज मैम कोई बुक बता दीजिए, एक्चुअली क्या है कि हम लोग CSIR की मैं प्रिपरेशन कर रहा हूँ, तो थोड़ा सा एडवांस चाहिए, मतलब सर बहुत बेसिक बेसिक करवाते हैं, तो थोड़ा सा मतलब।
ओके, आई विल लेट यू नो। ओके, अदर दैट क्वेश्चन दैट वी वर डिस्कसिंग, और कुछ डाउट्स है तो आप पूछ सकते हो।
मैम वो जो बच गया था उसको थोड़ा सा सॉल्व
हाँ,
कर लेते हैं
इसको
ना।
करते हैं, इसको सॉल्व करते हैं।
यस मैम।
ये शायद कुछ गलत है इसमें, आई गेस क्वेश्चन में कुछ गलत है।
हाँ भाई अजय ठीक बोल रहा है। भाई अनम्यूट कर सकते हो अपने को, इतने दिनों से क्लास ले रहे हो, बोलते नहीं कुछ भी।
बट प्लीज मेंटेन द decency because it
डेकोरम
is
ऑफ द
going to be
क्लास।
uploaded. Yeah,
यस।
इसको ट्राई करो। इसमें या तो फिर इंटरवल गलत ले रखा है या कुछ मैप में ही गड़बड़ी है।
नहीं मैम आप इसका 1 3 का इनवर्स इमेज निकालिए ना पहले। 1 ओपन 1 3 की इनवर्स इमेज क्या आएगी?
वही
अच्छा वो
वन
लाइब्रेरी में। यस मैम।
1,3 की इनवर्स इमेज निकालनी, राइट, अपने को। सो
यस मैम।
टिल 2 वी आर गेटिंग हियर, राइट
मैम
नाउ।
ये जो यहाँ पर होगा इसकी इनवर्स इमेज, वो जो फर्स्ट इक्वेशन है वहां से गवर्न होगी ना इसकी, एक्स इज लेस देन आर इक्वल टू 3, तो एक्स
हाँ,
माइनस 1 वहां से
तो
गवर्न होगी 1 हाँ जी।
वो 2 तक रहेगा, राइट?
टू तक तो रहेगा, वो इक्वलिटी
हाँ,
है वहां पर,
हाँ,
एक्स लेस देन आर इक्वल टू 3। यस मैम।
हाँ, वहां तक रहेगा, ठीक है, तो 2 तक रहेगा वो। फाइन। तो
टू
2
तक
तक
हाँ,
इट
इनवर्स
इज
इमेज ना।
satisfied. हम्म।
टू
2
टू
tak it is
4।
satisfied. Now we are talking for further, that is given by y is equals to half times x plus 5, right?
जी।
तो यहाँ से आपको x क्या मिल जा रहा है? So x
एक्स इज
is
इक्वल टू
2y
2y
minus 5.
माइनस 5।
ओके,
यस
तो इनवर्स इमेज ऑफ, अगर आप ये इंटरवल में 3 पे निकाल रहे हो तो क्या मिलेगा?
मैम 3 तक वो फर्स्ट वाले से ही गवर्न होगा ना एक्चुअली, क्योंकि
हाँ,
वो एक्स लेस देन और इक्वल टू है 3, इक्वलिटी है 3 पर।
यहाँ इनवर्स इमेज ऑफ इसकी बात कर रही हूँ मैं। ये वन
हाँ तो
कॉमा
वो
थ्री
वही
कहाँ है? को डोमेन में है ना?
1 जी।
तो यहाँ तो आप बात कर सकते हो ना, 3, 3 पे इनवर्स इमेज क्या आएगी? सॉरी, इनवर्स इमेज
वहीं
ऑफ
से
3 क्या होगा? इनवर्स इमेज ऑफ 3 क्या होगा?
4 आएगा 4।
कैसे 4 आएगा?
एक कोडोमेन में है तो कोडोमेन में जो एक्स लेस देन आर इक्वल टू जो 3 है, वहां से तो गवर्न होगा ना उसका इनवर्स इमेज उसकी, जो मतलब माइनस इन्फिनिटी से क्लोज 3 तक जो मतलब इंटरवल है वो सारा फर्स्ट वाले से गवर्न होगा, मतलब उसकी इनवर्स इमेज
हाँ,
y इज इक्वल टू x इज इक्वल टू वाई प्लस वन।
पर ये कोडोमेन की बात कर रही हूँ मैं।
कोडोमेन में ही बोल रहा हूँ ना मैं।
तो ये थ्री तो कोडोमेन में
कोडोमेन
नहीं है ना, ये थ्री कोडोमेन में है, ये जो हम थ्री तक की बात कर रहे हैं वो डोमेन में बात कर रहे हैं।
इनवर्स
एक्स,
इमेज तो कोडोमेन में होगा। हाँ जी। द
हाँ,
इनवर्स इमेज ऑफ द ओपन इंटरवल 1 3,
हाँ।
तो ये तो कोडोमेन में है ना, तो कोडोमेन में कहाँ से आएगी इसकी इनवर्स इमेज? वो
तो
तो वो
y
वाली
को
इक्वेशन
y
होगी।
को अगर आप थ्री पुट कर रहे हो तो क्या मिल रहा है?
y इज इक्वल टू 3 रखेंगे तो इसकी इनवर्स इमेज वहां से आएगी, y इज इक्वल टू एक्स माइनस वन, मतलब x इज इक्वल टू वाई प्लस वन। अरे आप करके देख लीजिए ना उसकी 4 की। अच्छा मैम, ठीक ठीक। ठीक
समझ में
बोल रहे
आ
हैं
रहा
आप,
है
समझ गया मैम।
क्या बोलना
फोर
चाह रही
वो
हूँ मैं।
फिर, हाँ, 3 से बड़ा हो जाएगा वो 4, फिर वो उधर चला जाएगा नीचे वाले।
हाँ, वो नीचे वाले में चला जाएगा
ये-
ना।
हाँ, लेकिन मैम इसकी इनवर्स इमेज अभी क्लियर नहीं हो पा रही है 1 3
हाँ,
की।
वो तो क्लियर नहीं हो पा रही है, वो तो क्योंकि अ, इसके आगे का
ब्रीफली
हमको
मतलब।
पता नहीं है,
जी।
राइट।
हम्म।
बट हाँ, थ्री तक है कि टू तक मिल जाएगा। ओके।
2 तक।
हाँ, थ्री के लिए आपको टू तक मिल जाएगा।
ब्रेक करना पड़ेगा क्या, मुझे लग रहा है बीच में
क्या
कहीं।
चीज?
2 से ब्रेक कर लीजिए, जैसे सपोज 1 3 है तो 1 क्लोज टू यूनियन ओपन टू 3।
अगर हम यहाँ पे थ्री पुट कर रहे हैं y की जगह पे, सो व्हाट यू आर गेटिंग, तब हमें x इज इक्वल टू वन मिल जा रहा है।
यस मैम।
इस पॉइंट पे हमको x वन मिल रहा है।
पर तो 1 मिल जाएगा मैम, 2 की में 1 आ जाएगी।
हाँ,
पर हम 3 चाहिए, 3 कहाँ से मिलेगा? 2.3।
सो ये है तो कुछ सही, बट कुछ है यहाँ पे, या फिर क्वेश्चन में कुछ डिफिकल्टी है।
इमेज में डिफिकल्टी है मैम, क्वेश्चन तो ठीक दिख रहा है।
क्वेश्चन भी ठीक है, इनवर्स इमेज भी आई गेस ठीक ही है।
अच्छा, ये है मतलब आप उसको थोड़ा सा डिस्क्राइब करिए।
तो कर रहे हैं
कैसे?
ना। तो so here we are getting y is equals x is equals to 2y minus 5. Okay.
मैम 4 की इमेज भी तो 3 ही आ रही है।
हम्म।
4 की इमेज भी तो 3 आ रही है ना,
हाँ।
मतलब वो नीचे 3 के 1 होगा तो 4 दूनी 8 माइनस 5 3 आ जाएगा वहां से भी।
हम्म।
4 की इमेज भी 3 आ रही है, इसमें भी तो आ रही है 4 की इमेज 3, तो ये तो ठीक दिख रहा है मुझे।
This we have got 2 3 at closed. Choose of the open
वो
interval
4 की इमेज
2.
मैम 9/2 आएगी ना, 4 की इमेज।
हाँ, 4 के लिए तो आपको 9/2 मिलेगा, दैट इज यहाँ पे मिलेगा 4.5 पे, यहाँ पे। For 3, the inverse of the open interval
मैम
3.
एक क्वेश्चन मैम, जैसे ये 3 है कोडोमेन में, तो
हम्म।
हमें जैसे इनवर्स इमेज निकालनी है तो हम ये देखेंगे ना कि 3 कहाँ लाई कर रहा है, मतलब उसका तो कुछ रिलेशन होगा ना, वो जो
द
जैसे डिफाइंड
इनवर्स ऑफ द
फंक्शन।
ओपन इंटरवल आपको निकालना है ना, 1,3 निकालना है, ठीक है, तो ये यहाँ लाई कर रहा है 1,3। ठीक है। अब आप इसका देखोगे ना कि ये जो आपका मैप है उसको वो कहाँ कहाँ कट कर रहा है इस रेंज में।
हम्म।
ठीक है। And according to this statement, it is saying that it should be open 2 and closed at 3. But how? कुछ मिल रहा है?
माइनस में बनाए क्या मैम? माइनस में कुछ रख के,
ट्राई करो।
माइनस में मतलब, यस मैम।
Inverse of the open interval 1 comma 3. So at 3, आप ये जो सेकंड वाली लाइन है इसका ग्राफ प्लॉट करने की कोशिश करो। हाफ टाइम्स y इज इक्वल टू हाफ टाइम्स x प्लस 5। फिर वहां से मिल जाएगा।
ये तो 5 यूनिट ऊपर से जाएगी लाइन, एक्स एक्सिस के
एट
अबाउट।
x इक्वल्स टू 1 आपको क्या मिल जाएगा? ये लाइन पे एट x इक्वल टू 1 पे 3 मिल रहा है, राइट?
हाँ, 3 मिल जाएगी, यस मैम।
फिर एट x इक्वल्स टू 2 व्हाट यू आर गेटिंग?
एक्स इज इक्वल टू 1 यहाँ से कहाँ गवर्न होगा मैम? एक्स इज इक्वल टू 1 तो ऊपर वाले से आएगा ना, वो लेस देन आर इक्वल टू 3 है।
नहीं नहीं, अगर आप ये इस लाइन की बात करो, इस लाइन को अगर आप प्लॉट कर रहे हो तो ये लाइन भी तो यहाँ से पास होगी। हम फंक्शन की बात नहीं कर रहे हैं। नॉर्मली अगर आप ये लाइन की बात करो हाफ टाइम्स x प्लस 5, देन
6 है, वो 3 आ जाएगा मैम 1 पे।
हाँ, इट
1
विल
पर
बी
इसकी इमेज 3।
3.5 आएगी, राइट? 1 पे 3 आ जाएगी, 2 पे आ जाएगी आपकी 3.5, 0 पे आपको मिल जाएगा 2.5, राइट? ये कुछ ऐसे जाने वाली है। एंड ऑन -1 यू विल गेट 2। -1 पे आपको 2 मिल रहा है, ठीक है? So the inverse of the open interval
मैम ये जो इंटरवल दिया हुआ है, मतलब जैसे फंक्शन डिफाइंड एफ, तो क्या हम वाई की रेंज फाइंड आउट नहीं कर सकते हैं?
हाँ
जैसे
कर
वो एक्स लेस देन आर इक्वल टू, तो वो रेंज उसकी अगर फाइंड आउट हो जाएगी तो फिर उससे पता चल जाएगा,
तो रेंज ही तो निकाल रहे हैं।
मतलब वाई की
लाइन।
रेंज।
हम्म।
तो अगर सपोज ये एक्स अगर इन्फिनिटी टू 3 में लाई कर रहा है तो वाई कहाँ पर लाई करेगा? एक्स माइनस 1।
तब y इस लाइन पर रहेगा, राइट?
टू, ये इन्फिनिटी टू 2 जाएगा मैम,
हाँ
लेस देन
वही।
आर इक्वल टू, ठीक है।
हम्म।
अब फिर वो, तो फिर अब उसके लिए वैसे ही फाइंड आउट कर लें, तो ये 3 हमारा मतलब उसमें दूसरे वाले में जाएगा मैम।
या ये क्वेश्चन इनवर्स ऑफ द ओपन इंटरवल एंड -1 पे आपको क्या मिल रहा था? ओके।
मैम मैम एक्चुअली थ्री जो है ना उसके उसमें डोमेन को डोमेन में ही नहीं थ्री, थ्री उसके को डोमेन में ही नहीं, तो कहाँ से उसकी इनवर्स इमेज निकाल पाएंगे? थ्री रेंज में नहीं है मैम उसके,
हाँ, 3 उसके रेंज में नहीं है इस फंक्शन के।
तो फिर इनवर्स इमेज कहाँ से पाएंगे उसकी?
हाँ,
अगर उसकी हम,
तो आपको
तो हम
कोई
थ्री
और
की फिर
इंटरवल।
इनवर्स इमेज, जी,
तो 3
ये
उसके
जो मैम
रेंज, इसलिए तो यहाँ पे
इसकी
ओपन
जो
इंटरवल ले रखा।
तो फिर हम तो थ्री की नहीं निकाल सकते ना, तो हम थ्री पर क्यों
हाँ,
इंसिस्ट कर रहे हैं?
ओके,
थ्री
तो
की हम क्यों निकाल?
3 का मत निकालो, उसके पहले का देखो, पहले के पॉइंट्स के लिए क्या आ रहा है।
जी मैम, ये एक्चुअली क्या है, इसका जो इसकी रेंज आएगी वो माइनस इंफिनिटी टू क्लोज टू यूनियन क्लोज ओपन फोर टू इंफिनिटी, मतलब इसमें से आप ओपन टू क्लोज फोर ये बाहर कर दीजिए। ओपन टू क्लोज फोर इज नॉट इन द रेंज ऑफ दिस फंक्शन। क्या मैम कंफ्यूज है क्या?
हाँ,
एक्चुअली देखिए
लेकिन मुझे
उसकी
वो
जो
चीज क्लियर नहीं हो रही।
देखिए फर्स्ट वाले
क्योंकि
जो फर्स्ट वाला, जी, जो वो एक्स लेस देन आर इक्वल टू थ्री है, तो वहां से जो y की जो मतलब y जहां पर है उसकी जो रेंज वहां से आएगी
हाँ,
वो
यहाँ पे
इन्फिनिटी
क्लोज
टू,
टू तक आ जाएगी आपकी, ठीक है, हाँ सही
जी
है।
जी जी,
फिर उसके
इन्फिनिटी टू
बाद
क्लोज
से 3 के
फोर
बाद
से
के
फिर स्टार्ट
पॉइंट्स के
होगा
लिए
ओपन,
आप कह रहे हो
ओपन
4 के बाद से।
ओपन फोर टू इन्फिनिटी,
हम्म।
ये इसकी
और
रेंज बनी। यस मैम।
व्हाट अबाउट अगर हम 3.5 पे ले तो?
3.5 इज नॉट इन द रेंज, वी कैन नॉट फाइंड इनवर्स इमेज ऑफ 3.5।
एक्स पे अगर आप 3.5 ले रहे हो, यहाँ तो आप ले सकते हो ना, एक्स ग्रेटर देन 3 का है, राइट?
एक्स को ले सकते हैं लेकिन इनवर्स की इनवर्स इमेज की बात कर रही है ना आप,
हम्म
3.5
हम्म
की,
हम्म।
वो नहीं निकलेगी क्योंकि वो रेंज में ही नहीं है
ओके, सो
3.5।
तो यहाँ पे जब आप इन्वर्स इमेज लेने जाओगे तो
रेंज में होना चाहिए ना, तभी तो इनवर्स इमेज निकलेगी।
हम्म, तो फिर ये आ
इसकी
जाएगा
रेंज
आपका
क्या बनेगी
माइनस
मैम?
इन्फिनिटी टू टू आ जाएगा, राइट?
यस मैम, उसको लिखिए वहां
और
पर,
फिर यूनियन
यूनियन ओपन फोर टू इन्फिनिटी,
ओपन फॉर क्यू।
क्योंकि वो थ्री से स्टार्ट करेंगे ना उसको, थ्री मतलब उसके में उसमें है नहीं,
और
इसलिए
3 उसमें
ओपन
है ही
फोर।
नहीं, ओके, तो फिर आपको मिल जाएगा माइनस इन्फिनिटी टू टू
हाँ, क्लोज टू,
यूनियन
माइनस यूनियन
4
ओपन
टू
फोर टू
इन्फिनिटी।
इन्फिनिटी। यस मैम।
ठीक है, तो अब आप
यस मैम। अब ये बीच में जो ओपन टू क्लोज फोर जो इसमें है उसकी वो रेंज में नहीं है पूरे इंटरवल,
हाँ, तो
ओपन
आप
क्लोज फोर।
किसका इनवर्स इमेज लोगे तो आपको ये मिल जा रहा है। इसको प्रूव डिस्प्रूव कैसे करेंगे कि एफ इज नॉट कंटिन्यूअस?
हाँ, मैं जो टू फोर ले रखा था मैम, उसको देखिए टू फोर की,
ओपन
ओपन टू
इंटरवल
फोर,
2,4।
लेकिन वो उसमें है नहीं,
हाँ,
उसकी इन्वर्स निकलेगी नहीं। और ये उसमें एक्चुअली ओपन तो है ना ये उसमें, इसमें मैम आप टोपोलॉजी कौन सी सब स्पेस टोपोलॉजी लेंगे क्या? ये जो हम फंक्शन डिफाइन करते हैं वो मतलब
नहीं, ये
कॉन्टिन्यूटी जो,
टोपोलॉजी के इससे नहीं है। दिस इज
जी,
लाइक नॉर्मल इन रियल एनालिसिस। यहाँ पे हमने कोई टोपोलॉजी डिफाइन नहीं की है।
रियल एनालिसिस मतलब ये ऐसे ही स्टैंडर्ड
हाँ,
टोपोलॉजी,
मतलब स्टैंडर्ड टोपोलॉजी ले लो, आर पे,
यूक्लिड,
यूक्लिडियन।
तो उसमें तो वैसे भी, उसमें मैम अगर आप थ्री पर देखेंगी लेफ्ट लिमिट राइट लिमिट वो तो इक्वल नहीं आ रही ना।
वो तो नॉर्मली हो जा रहा है, और यहाँ पे भी दिख ही रहा है आपको कि इट इज नॉट कंटिन्यूअस।
हम्म।
ओके, बट was trying to find an open interval जिसका इनवर्स इमेज ना आए ओपन।
यही तो है, यही वाली ले लीजिए, ओपन टू क्लोज फोर, इसकी इनवर्स इमेज एग्जिस्ट ही नहीं कर रही, तो ओपन क्लोज होने कोई क्वेश्चन ही नहीं।
एग्जिस्ट नहीं कर रही है ना, बट आई वाज ट्राइंग टू फाइंड
हाँ।
समथिंग दैट will be of this kind, some open closed kind of. Okay, we'll see this. I'll try to see if I'll get something, or is there something missing.
ओके मैम,
So
थैंक यू।